Welcome to this introduction to C++ programming. As you are aware of the fact that we are using computer applications and Android applications, computer programming is the process of developing such applications. And these applications usually give instructions to the computer so that the computer will be performing the task needed for you. This course, you will learn the structured programming and object-oriented programming using C++. And C++ is an upgraded, improved version of the C programming language. And before we start anything about programming language or programming using C++, we will start with some basic fundamentals about the computer. A computer is a device capable of performing computations and making logical decisions. And this is true in the case of smartphones also, because the present day smartphones also work like a computer, and they are all working on the basis of a Linux based operating system. And when we come to a computer, it also has an operating system which may be Windows or Linux. But these devices, computers and smartphones, are capable of receiving instructions from human, and they will be able to perform accordingly to complete a task which we would like to do with these systems. And computers process data, and these instructions given for processing data are called computer programs. And computers have got a hardware, and these hardware components are the components which we can see, touch, and feel from a computer, like keyboard, screen, mouse, disk, etc. And it also has got a non-visible component which we cannot touch, we cannot feel, and they are called software. And these softwares are the backbones of computer, which permits us to use the hardware of the system. And there are two types of software systems available on a computer. They are called system software and application software. And to get more understanding about what is hardware and what are the software systems and what are the system software, I'm just using the example of a bus. And a bus which we use to travel has got its hardware, the machines, and it is a very complicated system. Usually, we are not able to follow the functions of the machines of a bus. But if you want to learn this, you will be able to learn the machine language of a bus to use the bus. And usually, a driver is doing this by by pushing certain switches and using certain levers, pedals, and the steering. He is applying the machine language. He is directly communicating to the machine of the bus. And it is a bit hard, but if you want to learn this, we can learn this. And if you want to use a bus for traveling, on the top of the machine, on the top of the hardware of the bus, we need two applications, I can say, called the driver and conductor for using the bus. And these two applications will permit you to use the bus. And if you want to use the bus, you get into the bus, and even though you are using the machine of the bus, you are not directly communicating to the machine of the bus. Instead, you will be communicating to the conductor of the bus for using the machinery of the bus. And the conductor, in a coded form, he will be communicating to the driver And this coded form of communication is very fast, is a single bell and double bell. So this is something similar to the assembly language of a computer programming, giving instructions in the form of uh, a coded form. So you are communicating to the conductor in the form of high level language, and the conductor communicates to the driver in the form of a coded form. In computer science, we call it as the assembly language. And the driver is communicating your instruction which you have given to the conductor. Finally, this communication will be given to the machine of the bus through the driver in the form of certain rotation of wheels, applying certain pedals, pulling certain levers, switches. So he will be directly applying to the machine of the bus. And in computer uh, framework, the the functions done by the conductor and driver are called the system software, or commonly we call it as the operating system. And the operating system accepts the commands, high level commands from the user. And in Siri and all, you can see, you can even talk to a computer system and it accepts your high level language instructions, and it will be converted into codes, and finally it will be converted into a language, machine language, which will be applied to the hardware of the computer system. And finally, your high level instructions will be applied to the system in a machine language form. Uh, and the functions done by the driver in a computer system is called the kernel of the operating system. And the kernel of the operating system will be directly interacting with the machine. And the functions performed by a conductor interacting with the user is usually called a shell of the operating system, which will be interacting with the users. And these are the six logical units of a computer. We have an input unit which will be accepting the input from the user. Usually we have the keyboard and mouse. Output unit, the monitor, printer, where we receive the output. We have a memory and which stores data. And this memory is uh, maybe similar to your brain, where you can store data, but this is not a permanent storage. In the future, if you are not refreshing this, it may be lost. And we have an arithmetic and logic unit which performs arithmetic calculations and logic decisions. Then we have a central processing unit, CPU, and the CPU supervises the entire operations of a computer system. And also we have a secondary storage unit, which is a permanent storage unit where which may be slow, but if you keep some data on a secondary storage unit, it is permanent and it is a long-term memory. It may be similar to your notebook. If you write something on the notebook, it will be there forever. But if you want to process information from notebook, you need to bring it to your brain. From there only you will be able to process this. Exactly in the similar way, if you store something on a secondary storage unit, then uh, this has to be brought into the main memory, the main memory unit of your computer. Then only the CPU and ALU will be able to process on this. And we have three types of programming languages, and this is maybe the evolution of programming languages. We have the machine language, where we directly interact with the hardware of the computer using a language known or which can be interpreted by the computer hardware. And since we are using a computer system, this instruction will be in the form of zeros and ones. And the instructions directly given to the computer hardware in the form of zeros and ones are called machine language of the system. And the computer, even if we have very complicated, very user friendly way of interacting with the system, the computer hardware can understand only a language of zeros and ones, that is a machine language, and all the instructions, all the programs which we give in other ways have to be converted into a machine language. Then, and modification as a modification to the machine language, later came assembly language. The assembly language is um, uh, using these assembly languages are using certain coded form of giving instructions to the computer. And as you can see, this uh, three codes are used for adding two values. So one value is loaded into the CPU, and then another value is added to that, and later it is stored into a third variable. So this is for performing a simple addition. And the advantage of assembly language is it is more easy to program from a programmer side, but it is not the machine language. It has to be converted into machine language through another software called the assembler. Then anyway, the machine can understand only machine language. And later came the high level languages where we can give high level language like instructions, which is very easy to program. But these high level languages also have high level language programs also have to be converted into machine language. Then only computer will be able to process this. And these software systems which convert a high level language program into machine level language program are called the compilers. So we need a compiler for converting high level language programs into machine language. We need an assembler for converting assembly level language programs into machine level language programs. And slowly we are coming to the C++ and C. C++ is evolved from C, and which is an upgraded version of C where we can have classes and objects. Then the ANSI C, it is a version of C which established standards for C programming. Then the C++ programming has got a OOPS object-oriented programming facility where we can define classes and objects that we'll be explaining later. And C++ programs have got classes and functions. And another advantage is there are a collection of existing classes and functions in C++, so that these classes and functions can be used in your program to make your programming easier. For example, you have a lot of collections for handling strings, a combination of characters, and also you will be having so many functions available, built-in functions available in C++ for managing mathematical operations like sine, cos, tan, etc. So you can use all these built-in functions uh, for in your programs so that it will be easier for you to program. And there are also, in addition to C and C++, there are many other programming languages available like Fortran, COBOL, Pascal, etc. And we have two ways of programming. Uh, Basically, one is called structured programming. And in structured programming, we structure a program. It is a disciplined approach to write your programs where you'll be starting a line and in which way spacing will be done. So if you follow a structured programming, then it will be easy for anybody to read and understand your programs. So it is a good practice to follow a structure for your programming. And there is also a concept in programming called multitasking, where your programs or instructions will be able to perform many tasks. And we will continue with the objects and classes in the second video. Thank you.